Hi guys, this is Vijay, your host. So today we are going to talk about that route leaking in the Nexus 9K devices. So what we have scenario here is we have the Nexus 9K as a core switches and 9K core switch is which has SVI 100 in the VRF rate. We have SVI 200 in VRF test. Okay, and these we have two hosts connected here. Okay, so this red VRF belong to this particular host. Sorry, this particular host, and the test VRF belong to this particular host. Okay, now our goal is to establish the communication between the two VRF. Okay, how we can do that? There is a 2-3 method in the Cisco Nexus devices. One is VRF to VRF communication. Second is non-default to default VRF communication. Okay, so that is, let me show the two method. Here's we have to, this we call that VRF to VRF method, which we are going to talk about the red and test. Almost same kind of connectivity we're going to have. We're going to have red VRF, then to global. Global means default VRF, okay? Global VRF. This we call that global to VRF. So there is two kind of test traffic which you usually need. Suppose your default VRF having some SBI, you want to access this particular VRF, or if you have two different VRF, how are you gonna create that static communication between them? Okay, and these are the connected devices. So I have the Nexus device. If I show that, so this is the so run interface VLAN 100 I have. Sorry, so run interface VLAN 100 I have, and the show run interface VLAN 200 I have. This is the 10.10. IP address from the VLAN 100, 20.20 from the VLAN 200. So if I copy from here and paste it over here, okay. These SBI are created on the core switch. So wherever L3 configuration will be there, we have to perform the configuration of the route leaking over there. So we have to do the VRF leaking on Nexus 9K. What version we're going to have in the Nexus 9K devices? We have show module. This is show module 9. Something version. We have like 9.2 version running. So it doesn't matter whether it's a 9.2 or 9.3 or 7.x. The concept of the route map in the 9K device is going to be same. So how are we going to achieve that here? This route map. Okay. So this is the physical connectivity which I've showed you. Right? This is the physical connectivity. Okay. Physical layout. Now we are going to see the logical layout of the VRF leaking. How are we going to achieve that VRF leaking here? Logical layout. We have one box. We focus going to be only on the core switch device. We are not going to touch any other devices. Okay. So VRF is a locally significant VRF. Sorry. And 9K core. Okay. We have two SBI connected here. SBI 100, SBI 200. SBI 200. We have SBI 100. Now we have two VRF in front of them. One is from this one. One is for this one. Okay, this VRF we call the red. This VRF we call that test VRF. Okay, now there is two types of method. Either you can achieve the inter-VRF routing through the PVR or using the BGP process. Through the BGP process, you can achieve the BGP inter-VRF routing. So you have to create the one BGP process, and you have to redistribute these subnets. These VRF will talk to each other through BGP. Here's number, for example, 20. I'm going to select. These two VRFs we will be talking to this particular BGP. Do I need to establish any communication neighborship? Answer is no. This is just to, you have to create the process. BGP will establish the route between the VRF. You do not have to create any neighborship between this test VRF and red VRF. Okay, I will show you that. So what we have to do, we have to redistribute this particular SBI of the red VRF into the BGP here. Same thing for 200 VRF redistribution into the BGP. What we have to do? We have to redistribute directly connected. Or if you have some like static route something, you can distribute that. Redistribute directly connected. Why we are saying the directly connected? Because SBI is connecting directly to this particular VRF. If I go to the VRF red, so IP route VRF red. This is particular route we have in red VRF. Okay, let me copy paste it here. In the red VRF, we have this particular route. This is the routing table of the red VRF. In the red VRF, 10.1.1. subnet is my IP address, which should be talking to the SBI 200. What is the SBI 200 routing address? In the test VRF current IP address, so IP route VRF test. Right? This is the routing of the test VRF. If I go here, this one. This is the routing of the test VRF. If you see that 10.10. subnet is missing from here, and 20.20. subnet is missing from the here, right? How are you going to do that? Just give me a second, guys. Let me copy paste in a better manner. This one, and if I copy this particular VRF from here, if I go to here, I will remove this, all this hurdle. I will remove all these subnets. I will just keep focus on the 10.10. subnet, which is locally learn here route. So we have 10.10. subnet, 20.20. subnets. So in each VRF, our goal is to install this 20.20. subnet in the VRF red, and 10.10. subnet should be reachable to the VRF test, right? This is our goal. So what we have to do here is there is a process in a 2-3 process. First thing is you have to create the, so there is two methods. Either you advertise everything, whatever belong to the red VRF to the test VRF to the red. It means import, export everything. Now, second is you control a specific subnet for the redistribution. Suppose, for example, you have SBI 300, SBI 400. There are a bunch of IPs are there, but only you want to export the SBI 100, right? To a specific subnet should be communicating, not the all. So for that, you have to configure through the prefix list. What we are going to do here, we are going to redistribute only a specific subnet. If you do not specify that specific subnet in the redistribution on the BGP, entire routing will be redistributed into the BGP. Okay, so what we have to do here is also we have called that RT, route target here. What is the route target? Route target is the distinguished number which each VRF contain for the uniqueness of its traffic. Okay, I'm going to give this particular RT value, and what I'm going to do here is I am going to tell this particular VRF I am going to export this RT value. Okay, export this RT value. You make sure you import this 1.1. Okay, here we go to export 1.1. Then what I'm going to do here is again for the test VRF, what I will do here is opposite. I will say that test VRF, I am going to export my 2.2 subnets. Whatever I'm going to export from the test VRF to red, make sure it has the 2:2 tag value. Then I said that I'm going to import, if any route is coming in my table, this particular tagging, I am going to install in my table. Okay, so let's start that. First thing is I will create the prefix list. So I already have template here. So first thing is I have already SBI here. I will create the prefix list. This is for the red VRF. So currently I'm going to focus only one VRF for now. Okay, I'm going to export this red router of SBI, red VRF SBI into the test VRF. That's one way, okay? Once you've done the verification, then I will export in a second phase, this one, test VRF to the red VRF, phase 1, phase 2. Let's establish the phase 1. The phase 1, what I'm going to do here is I will select that SBI 100 IP address, which we want to export that. Then I will create the route map. I will say that match IP address prefix list, I will say the red, right? I will call this prefix list inside the route map. Then I will say that I will create the router BGP for VRF red address family. I will redistribute connected, or you can say direct. Direct. Why we have direct? Because if you see that SBI is showing that direct here, it means it's a locally connected. I will say route map. Then I will call the route map inside this redistribution policy. Okay, then I will say here is in the step number 2, I will say that I am going to export 1/1. I'm going to export 1.1 and test VRF going to import 1.1. Okay, the moment I will say this one, you will see that test VRF should be receiving this particular subnet. So let's go ahead. Okay, so I will say prefix list done. Then I will say route map creation done. If you have multiple subnets, you can create a multiple prefix list. Okay. Then I will create the BGP with that distribution is spelling is wrong, I think. Okay. Then I will do this one. Both configuration is step number 2. Now let's do the verification. Configuration is done for the one way, phase 1. If I show here, show IP route VRF red. Red should not have 20.20 entry, right? Currently, it has not. It does not have 20.20 subnet. If you see that, same thing for the test VRF. Test VRF has 10.10 entry from the red VRF. Via where? Via BGP. Look here, right? Same thing I will do for the phase 2. Now, in a phase 2, I will export this particular subnet into the red VRF, right? Currently, red VRF has no 20.20 entry. Now, after the, let me paste that verification command. After leaking, you'll see that this subnet. And this is the after leaking. Okay, 10.10.10 subnet is coming via the red VRF. Same thing I will do for the, let me clear this first. Same thing I will do for the test VRF. So what I will do here is I will just copy simple this configuration. I will create another tab saying that this is a VLAN 200. Right? I have 20.subnet. I will give different name. I will say test prefix list. Make sure that you should have the unique prefix list. Then I will say that test VRF route map. I will get different route map. I will not change the AS number. Here I will update the route map. Then I will say that import 2:2. Why 2:2? Because it has a route. I'm going to give this route target 2:2 for the test VRF. I'm going to export the 2.2 to the red VRF. Red VRF will import that route from the test VRF. Okay. Then I will say that export 2:2. Then I will say that let's configure that. Then I will say route map creation. And I will do for the like BGP for test VRF, not for this test VRF. Make sure that. Then I will run the step number 2. which is to import and export the route. For example, if I go and check now, so IP route VRF read, you will see that currently route is not installing in the table. After running this particular command, router will install the routes 20.subnet in the routing table. Now, if I show here, now if you see, so IP route VRF test first, test at 10.10.10, then I will say read. Read has, should have, just give me a second. Let me check, did I something? Okay, so in the route map, you will see that the route map has wrong matching. Okay, I will say the read no to this. And then I will say add, because it does not have any. Read has 10.10.subnet, right? That's the reason it's not showing here. So if I modify this, that was the configuration wrong. Show IP route VRF read. Look here, read VRF saying that I got 20.20.subnet from test VRF. Look here. If I go and copy paste, I cannot copy paste here. Here. Okay, test read VRF is saying that I got this subnet. Now, suppose if you have 2-3 SBIs here, right? So let me create the SBI and let's keep adding that. I will add one more SBI. I will say that I have SBI 300 in a read VRF, right? Then I will say SBI 400 in VRF test, right? Then I will give 30.1.1.1/30 Then I will give 40.1.1.1/24, right? Let me configure this VI and assign the VRF first. I will say that VLAN 300 VRF member, sorry, VLAN 400, L2 VLAN first created. Then I will create interface VLAN 300 VRF member read. Then I will say IP address 30.1.1.1/24, right? No shut. I will say interface VLAN 400 VRF member test. Then I will say IP address 40.1.1.1/24. No shut. If I say so interface brief VRF all the interface should be up and running. If you say 400 is up, okay, and 300 is also up. Before the 300-400 configuration, can we ping from 200 test VRF to 10.10.subnet, which is sitting in a read VRF? Can we ping that? So let me check that. Ping 10.1.1.1 from VRF test. Look here. If I try to ping 20.20.subnet, which is test VRF IP address, from where? From VRF read. Okay, both are reachable now, right? Now let's configure this particular two subnets which are configured there, 300 and 400. So what I will do here is, since I already have the policy, what I have to do here is, the advantage of using the prefix list is you just have to match the name. I will create another prefix list. I will say that 30.30.subnet also allowed. I do not have to touch anything because read prefixes I will keep the same name. So if we are saying under the VRF read, I have created one more SBI. Please redistribute that particular SBI into the test VRF. So what I have to do, just add the prefix list, nothing else. Look here. Now if I go here, so IP route VRF test, you will see that 30.30 the subnet is also coming. Right? If you say the VRF read, it should not have 40.subnet, right? Because I have not created any prefix list. So IP route VRF read. We say 40.40.subnet is not there. The moment I create this 40.40.subnet here also, 40.subnet, it should be visible into the VRF red also. Right? If I say show IP route VRF red. Done. Now if I try to ping 40.subnet using the VRF red, should be reachable. Right? So this is all is about the VRF leaking. If you have the red to global VRF, the concept will be same configuration will be there. Okay, you just have to do the route tagging and all with the default VRF and everything, or else you do not have to do this kind of activity. But this is the best way which you can do for the VRF leaking. Okay guys, thanks for watching. We'll see you in next session.